And this is question 6. We're now working on page, let's have a look, 357, question 6, the same exercise. I'll be doing a video per question. This will be the last question I'll be doing in the exercise before we do the final assess of the entire GCSE. It says for each of the graphs A to C, well here they are, y equals f of x, y equals f of x, y equals f of x. In other words, they've not defined these in terms of a given function, an equation we can understand. I'm not sure that such an arrangement would have an equation anyway, just by looking at it. It looks really awkward. But anyway, they're defined as generic functions. Each one is called f of x, and for each of these sketches I've got to transform them and describe them. In other words, I've got to do y equals minus f of x for each of these three. I've got to do y equals 2f of x for each of these three, and I've got to do y equals f bracket x minus 1 for each of these three. So I've got 9 little sketches to transform, and what I've done is it's done copies on the other side. So let's just do the minus f of x first. Now if you recall, if I do this one and call it y equals minus the function of x, you may recall minus f of x means reflects in the x-axis. So if I extend these lines just a little bit and try and make it look real, and let's just try and draw it now. I'll stick to red and I'll try and make it like this. Now if I'm going to reflect in the x-axis, I'm going to start at the point 1/2, 0. The simple reason being is because if I'm on the x-axis anyway, I can't reflect in it because I'm actually on it. So effectively, if I continue this line as follows, I'm going to end up with something like, it should be red, shouldn't it? Yeah, I'm going to end up with something like that, and this side will be something like that. So this is the reflection of this line here, and this red part is the reflection of that line there. Now what is important is that I label the coordinates right there, label it in blacks. This point, if I'm told that's 0, 1, this coordinate, and this coordinate here has got to be 0, minus 1, and that's the only coordinate I know is absolutely true. And of course I know that the coordinates 1/2, 0 is there, and it's correct, so it's given me the question. So effectively this is a reflection. Let's look a little bit better. Reflection in the x-axis. Right, straightforward. Let's go back and find out what the question was again. Right, I must now do 2f of x. Here I go. So I now want to transform the general function of x into y equals 2 times the function of x. Now you may recall that the generic function a f x means multiply the y coordinates by the a. In this case it's 2. So I know, for example, 2, 0, the y coordinate is 0. If I multiply that by 2, it stays as 1/2, 0. But I know 0, 1 will become 0, 2. So if I put a little x there to make it look accurate, so this branch would actually look like this. If I draw it in with this now, so this part of the branch will look like that, and this part of the branch will look similarly like that. Effectively, I've stretched it by a scale factor of 2 in the y direction. Is that alright? So that's what's happened. I've stretched it vertically, and that's probably going to be the point something 2 anyway, because it's completely opposite the coordinate that I've tried to mark out in black. So what I should do really is show that I've understood what I've done and label the key coordinates just there, and that key coordinate is 0, 2. Alright? So it doesn't look like it's completely made up, but it does actually make sense. So 0, 1 gets transformed to 0, 2, and likewise, and whatever coordinate was here, it gets pushed in towards the y-axis like that. Okay, it's been stretched that way. So what is this? It's a stretch in the y direction of scale factor 2. I just want to check that one. One-way stretch in the y direction scale factor 2. Yeah, no problem. Let's do the next one, and I can't remember what it is. Right, so here it says I've got to transform it and become f bracket x minus 1. Okay, so here's my original function of f of x. I'm going to go y equals f bracket x minus 1. We've not done one of these for a very long time except in the original video, and you may recall if it's f bracket x minus 1, it moves to the right hand side 1 whole unit. So the key point is, if I'm moving 1 unit in this direction, I'm going to go from 1/2 0 here to 1.5 0, say here. Make it look approximately right, and it's important to label that point. That is the point 1.5, comma 0. So I can now try and draw this transform function. Again, that's going to be parallel. If I start from here, that looks about right, doesn't it? And over this side as well. Effectively, I've taken this graph and moved it in that direction, like so, along the x-axis to the right. So this is called a translation of y equals function of x using the vector, and this is important, I've gone 1 across and 0 up, alright? So I've moved 1 across in the x direction and I've not gone up and down at all, alright? Vector 1, 0. Straightforward? Yes, I got that right. No? Let me have a look at that. Translation 0, 1. No, I'm afraid the answer book is wrong. It's not 0, 1, it's 1, 0. I moved it to the right 1 unit, which is 1, 0, and not 0, 1. Thank you. Right, here we go. Let's just turn over the page. Let's have a look. I've got to do the same set of functions to the other graphs. Okay, so let's go back to blue. I'm going for y equals minus the function of x. Remember, this is the reflection in the x-axis, so this is quite difficult. This little branch would do that, and this little part would do that, and this part would come down here and do this, sort of, and this part here would come down and do this. And again, there's no key coordinates to, and of course the axes get extended like so, you know, there's nothing special there. There's no key coordinates to mention, it's just merely a reflection in the x-axis again. Reflection of y equals function of x in the x-axis. Right, very straightforward. Now the next one, I can't remember what it was, let's just look. Oh yes, 2f of x. So here I'm going to go for y equals twice the function of x. So let's just take a look. Quite difficult really to draw this one. Got to stretch it times 2, so 1, 0 remains as 1, 0. Right, and if that's, say, half minus 1, that'll become half minus 2. So I'm just going to plot a few points in my mind. That would get stretched this way, that would get stretched this way. What else? If that's that point there, would get stretched this way. I think we're looking at something like this. We'll pass through this point, up to here, then up through the point 1, 0, and like so. Alright, it's very hard to draw. It's effectively a stretch in the y direction by a scale factor 2. Very, very hard to draw that. Yeah, there's no visible change compared to the original, except this is meant to be more stretched. I suppose I ought to make it look a bit more like the original by doing this. So coming at it like that, say, and that's okay. Hits the 0 and through again. Yeah, there's no further change, but it's still the stretch in the y direction using a scale factor of 2. That's all there is to say about that one. Now this one here, I seem to recall it's y equals function of x minus 1. So you take 1 away from the x value, then apply the function, and this is going to shift this way 1 unit to the right. Okay, so it's going to be a translation using vector 1, 0. Okay, let's see if they got the answer book got that right. Yeah, they're still saying it's 0, 1. It's so not. It's 1, 0 because we're shifting it to the right. They got it absolutely wrong. Right, So 0, 0 becomes 1, 0. Let's get some key coordinates in there. 0, 0 becomes 1, 0, and 1, 0 becomes 2, 0, about here somewhere. So it's worth labelling this point 2, 0. And minus 1, 0 becomes 0, 0. So I'm looking for something that goes lumpy like that. Quite hard to draw, so let's just try and go for it anyway. So let's do the transformed one in blue. Oh, horrible, horrible, horrible. Right, here we go. Let's go. So draw. That goes like that. Then that goes like that. And up it goes. Really, really hard. You see, my blue part, my transformed function, sits over this red little hump here and comes back down. Let's make this look more even. So try that again so it looks right. So this is going to be more of a even dip like so, and that's it. I effectively moved 1 unit in that direction, 1 unit in that direction. Therefore translation using vector 1, 0 and not 0, 1, because that's just wrong. Next thing, let's go do the same with this lot. Y equals minus function of x. This one's going to be y equals 2 function of x, and this one's going to be y equals the function of x minus 1. So again, this is a reflection in the x-axis. Let's try and make it look good like that. Let's try and draw it in blue. Right then, so we've got something like this, and then this part will become a bit more like that, and this part will look a little bit more like that. Far from perfect. Again, no key points to quote there. Still 0, 0 and 1, 0, and this is still a reflection in the x-axis. That's that one done. Now this one, again, we need to try and stretch it in the y direction using scale factor 2. Scale factor of 2, and that's a stretch in the y direction. Well, I have no coordinates there, but that's a key coordinate. That will be half something. If I'm going to multiply by 2 on the y, it's going to be something like that. So we're looking at a transformation that looks something like this. So it's going to be more pointy there. Hit 0, 0, climb up to that point, come back down to here, and up through again. Alright, so that's me multiplying the y coordinates of each point by 2 and creating a stretch in the y direction of scale factor 2. Again, you can't really see what the answers are here because they look exactly like the question, the original question from the book anyway. Again, as you can see, the blue line looks, the blue transform function looks very similar to the red one as was. Anyway, this next one would stick up like a sore thumb because it is a translation of y equals f of x using vector 1, 0 again. Now, has the book got it right? No, they're still calling it 0, 1. It's completely wrong. It's not. We're going this way by plus 1 unit. So 0, 0 becomes 0, 1, and 1, 0 becomes, sorry, 0, 0 becomes 1, 0, and 1, 0 becomes 2, 0. So I'm looking for something like this. Let's try and draw this carefully. It's really hard. Right, so you're going to go like that. Hit this, create a hump like that, and then go off again. There you go. And you've got a key point right there which should be labelled as 2, 0. Very important to show you've transformed it correctly. Alright, and this shouldn't look quite as wavy. It should look more like that, coming round and dipping down, and still wrong. Let's try and aim for that carefully. It's really hard. So you go to 1, 0, and you come up and use a nice little hump, hit 2, 0, and off you go. And that's it. And that was a translation of the function y equals f of x using vector 1, 0, and not, definitely not 0, 1. I'm not lifting it up in the air. I'm moving it along 1 unit. And that's it. Thank you. That's question 6. And I'm now going to prepare for the assess.